Ever wanted to build a seriously fast modern web API using Python? Well, you are in exactly the right place. Today, we're going to build your very first API with FastAPI, and we'll do it step by step. Let's dive right in.
So what's all the hype about? Why are so many developers flocking to FastAPI? It really comes down to three killer features. First, it is blazing fast. We're talking one of the highest performing Python frameworks available. Second, it gives you automatic interactive documentation right out of the box, which is a huge time saver. And third, it's built on modern Python. It uses features like type hints, which makes your code super clean, intuitive, and way easier to work with.
All right, here's the game plan for today. We'll kick off with a deeper look at why FastAPI is so great. Then, we'll see how it tames messy data. After that, we'll get our hands dirty building the core of our API, learn how it talks back to us, and finally, we'll wrap up by making sure our code is rock solid with testing. Okay, section 1. Why choose FastAPI? Let's dig into those three pillars of power we just mentioned. Moving on, let's tackle one of the biggest headaches for any developer, dealing with messy, unpredictable user data. Luckily, FastAPI has an incredible secret weapon for this, and its name is Pydantic. Just picture it. You're expecting nice, structured data, but what you actually get is like a jumbled box of random shapes. That's the problem with raw data. A required field like an email, it might just be missing. Or maybe someone sends an age as the word 20 instead of the number 20. Trying to handle every single one of those cases by hand is a total nightmare and leads to really buggy code.
And this is where our hero, Pydantic, steps in. It's a library that FastAPI uses under the hood, and it acts like a strict but super helpful data police. It stands at the front door of your API, checks all the incoming data against the rules you set, and if anything doesn't match up, it gets rejected, automatically, with a clear error message. It's an absolute game changer. So how do we give the data police its rulebook? It's actually incredibly simple. You create what's called a base model. Think of it like a blueprint for your data. You just make a class and use standard Python type hints, things like name str or price float, to define exactly what the data should look like. Pydantic then takes that blueprint and turns that messy incoming JSON into a clean, predictable Python object you can actually trust in your code.
All right, now that we've got our data validation sorted, it's time for the training montage. Let's learn the 4 fundamental operations that are really the backbone of pretty much any API you'll ever build. And those operations are known by this handy acronym, CRUD. It stands for create, as in adding new data, read, for getting existing data, update, for changing data, and delete, for, deleting it. You master these 4, and you are well on your way to building powerful APIs.
First up, create. For this, we use the post method, and this is where that Pydantic magic we just talked about really shines. A user sends some JSON to our API. FastAPI sees our function is expecting that base model blueprint we created, and it automatically validates everything. If it all checks out, we get a clean object ready to be saved. No mess, no fuss.
Next up is read, which we do with a GET request. As the name implies, we're just retrieving data here. A lot of the time, you'll want a specific thing, so you use a path parameter, like students/1, to ask for the student with that specific ID. The most important thing here is that this is a safe, read-only operation. It should never, ever change any data.
Okay, on to update, which uses the put method. This is kind of like a combination of the last two. We use a path parameter to say which item to change, and then we send a JSON body with the new updated information. Now here's a little pro tip. It's a really good idea to use a separate base model for updates, one where all the fields are optional. This stops you from accidentally deleting data a user didn't intend to change.
And finally, we have delete. It's exactly what it sounds like. It removes a resource. Just like with reading and updating, we use a path parameter to tell the API exactly which item needs to go. When it's successful, you usually just send back a simple confirmation message, like, yep, student deleted.
So we've built an API that can create, read, update, and delete. That's awesome. But a truly great API doesn't just do things. It also communicates clearly about what it did, especially when things go wrong. So let's teach our API how to talk.
The language your API speaks is HTTP status codes, and the absolute easiest way to think about them is like a traffic light. Codes in the 200s range, that's a green light. Success. Everything works perfectly. Codes in the 400s are a yellow light. Well, hold on. You, the client, sent me something wrong. And codes in the 500s are a red light. Oops, that one's on me, the server. Something broke.
Let's start with the good stuff, the green lights, the 200 club. The best part here is that FastAPI is really smart. It handles this stuff for you with sensible defaults. If you get or delete something successfully, it sends back a 200 OK. If you create something new with a post request, it sends back a 201 created. It just works, right out of the box.
But what happens when things don't go as planned? Let's talk about a classic yellow light error, 404 not found. This happens all the time. A user asks for student with ID 99, but your database only goes up to 20. That's not a bug in your code, it's a client error, and your API needs to be able to report it clearly and correctly.
So how do we do that? Well, FastAPI gives us this fantastic little tool called HTTP exception. When your code figures out that a student doesn't exist, you can just raise an HTTP exception. You tell it the status code, 404 in this case, and you can even add a helpful message. FastAPI then does all the work of sending the proper error response back to the user. It's super clean.
And guess who's back to save us even more work? Our friend, the data police, Pydantic. If a user sends JSON where the structure is right but the data types are wrong, like sending the word 12 for an age that should be a number, Pydantic automatically rejects it. It sends back a 422 unprocessable entity error for you. You have to write zero code for this to happen. It's just brilliant.
Okay, we've built an API that works. It even communicates well. But how do we know it works? And more importantly, how do we make sure it keeps working as we add new features or make changes? The final, crucial step is building a safety net for our code. We have to test it.
So why is testing so important? I mean, this slide says it all, doesn't it? Untested code is like that shaky tower of blocks. You change one tiny thing, and the whole thing could come crashing down. But tested code? That's a solid pyramid. It gives you the confidence to make changes, to improve your code, knowing that your safety net will catch you if you break something.
And you might think testing an API is complicated, but FastAPI makes it incredibly easy with something called the test client. This is an amazing tool that lets you call your API directly from your test code. You can send GET, POST, PUT requests, the whole shebang, without ever needing to run a live server. It's fast, efficient, and works perfectly with tools like Pytest.
Now, there are two main kinds of tests you're going to write. The first is called the happy path. This is where you check that your API works correctly when everything goes exactly as planned. For instance, you'd post valid data to create a new student, and then you check two things. Did you get a 201 created status code back? And is the data in the response exactly what you expected? But, and this is every bit as crucial, you also have to test the sad path. This is where you intentionally try to break your API. You send a request that you know should fail, like sending a word where a number should be. Then you check to make sure your API fails in the correct way by returning the right error code, like a 422. This proves that your error handling is solid. So you see, the question isn't just, does it work? It's also, does it fail gracefully? And mastering both is the real key to building truly amazing, robust applications.